All right, guys. Plan is to give you a 15-minute revision video every night. So tonight's 15 minutes is going to be looking at this number booklet that we started today and picking out some number topics for you. Starting with rounding. I am not going to talk about decimal places. I will talk about significant figures for a minute, though. Okay. So one significant figure would be chopping the number after the first non-zero digit. Okay, nothing else will change. 0.000. Only decision, does the 6 stay as a 6 or round up to a 7? And in this case, because it's followed by a number bigger than 5, it rounds up. Whereas in this case, the 8 will stay as an 8 because it's followed by a 1. Here, the 3 will round up to a 4 because it's followed by an 8. However, because it's a big number, we do have to put these zeros in as placeholders. Same here, the 5 will stay as a 5 because it's followed by a 1. But again, with big numbers, we will have to put in zeros as placeholders. Same thing here, but we're chopping after 2 digits. Now, the first digit won't change. None of the zeros here will change. Neither will the 6. The only number that might change is the 7. And in this case, it does. It rounds up to an 8 because it's followed by an 8. Here, the 0.08 will not change. And here, the 1 will stay as a 1. The 8 will stay as an 8 because it's followed by the number 1, but we need a 0 placeholder. But here, the 1 will round up to a 2 because it's followed by a 6. And we're going to need 4 zeros to replace those. So that's significant figures. Okay. Which one will I do? I'll do the bottom one. Okay. Now, just want to show you there's different ways to do this. We've got to get the answer in index form. Okay. Option 1. I quite like 7 times 100 here because 7 is a prime number. So the prime numbers are going to be 2, 3, 5, and 7. Don't stop at things like 9 or 6. Remember, 6 is 2 times 3. 9 is 3 times 3. Might be 11. Unlikely. 100. You could go for 2 times 50. All right. 50, you could go for 2 times 25 or 5 times 10. Doesn't matter particularly here. And then 10, I'm having to branch sideways because I've run out of room. I'm going to go for 2 times 5. And once you get a number where both are circled, that kind of tells you that's the end of this. Now, in index form, there are 2 2s, this one and this one, times, not add, 2 5s times 1 7. Okay? Now, this question here is asking, is this a square number? Now, at the moment, the 2 is squared, the 5 is squared, but there was only 1 7 in my answer, right? So, what would I need to multiply this by to make it a square number? I would need to multiply it by another 7, add another 7 onto it to make it a square number. Now, don't worry too much about that bit. That's just me answering this kind of little thing I've done here. For each of the questions above, what would they need to be multiplied to make them square numbers? Remember, to be a square number, all indices in the answer need to be even. So the 2, the indice on the 2 was even, the indice on the 5 was even, but the indice on the 7 was odd, so we needed an extra 7, right? They could ask you something like this. Is this even or odd? Well, it's an odd number, so it's not a square number. However, if it was 2, 4, 6, 2, then it would be a square number because the indice is even. So even indices mean square numbers. Okay? Right. Okay, I've put some of these in here. I'll just do this one, okay? The HCF. So for HCF, we're going to need trees. So for here, I'm going to go, I could do 5 times 6. I'm going to do 2 times 15. And I'm going to do 3 times 5. Okay, and for this one, can't divide that by 2 because it would be 37.552. You don't just assume you can half things. We don't want decimals here. If you can't divide by 2, if you can't half the number, think about dividing by 5 or dividing by 3 or something like that. Okay, and again, that's 15. And 15 is 3 times 5. Okay, what's common. There's a 2 in this answer, there isn't one in here. There's a 3 in this answer, there's also a 3 in this answer. Take it out. There's a 5 in this answer, there's also a 5 in this answer. There's one there, all there. Take it out. What's left here is a 5. What's left here is a 2. Can't take those out because then they're not in common. Highest common factors we're looking for here. So 3 times 5 means that the HCF is 15. Okay. It does say though, the highest common factor, 15, is the square root of a number. What is the number? Well, if 15 is the square root of a number, then the number, and you've got a calculator, the number must have been 225 because the square root of 225 is that. Now, I was showing you here the difference between lowest common multiple, where I started writing out the times table, the 12 times table, the 18 times table, the 24 times table, using a calculator. And I was looking for the lowest number in all of their times tables, which turned out to be 72. I then did the highest common factor of 36 and 54. Noticed that I had to take a 2, a 3, and a 3 out. And when I times those, I got 18, and then divided them. 72 divided by 18 is that. Okay, bits and bobs I've done here. Okay. Put these in your calculator, put it in your calculator as it is, okay? Write the answer down. Okay, a couple of rules for you here, right? The rules are, if you're multiplying the same thing, so for example, if it was x times x, and there was a 7 there and a 4 there, then you would add the little numbers, and that's what you're doing here. So for example, that last one is going to be 2 plus 2 plus 2 plus 2, okay? If you're dividing, apologies about the mess, if you're dividing, for example, x to the power 7, and we could write divide like this, x to the power 4, you take away the indices. So, for example, this one here would be 5 to the power 3. Right? It's all become a bit of a mess down here, my apologies. In fact, what I might do is take you just down to here, okay? The other rule I want you to be aware of is anything to the power 0 is 1. Whether it's a number or a letter, okay? And then these ones, what I'm doing here is I'm going, look, if that minus wasn't there, 4 squared is 16. But if there's a minus indice, it becomes 1 over 16. So the last one here, 6 to the power 1 is just 6. So 6 to the power minus 1 is 1 over 6. Nothing to do with being negative. The minus indice means 1 over. So let's have a look at these. Right, it's a times in 1. Simplify. So we're simplifying. So we're using our rules. That's what that means. So 6 times 3, do the numbers first. 6 times 3 is 18. And then P6 times P cubed, add the little numbers, P9. Here, divide. Put into your calculator 3.4 divided by 13.6. And it actually tells you that that's 1 quarter. Make sure that they're the right way around. Then do the little numbers, G8 divided by G2. We'll take them away from each other, G6. Now, that's what I was expecting to see. I did the numbers, then I took away the little numbers. However, the way they've written that is instead of written 1 quarter, they've written it as divided by 4, bit nasty. And then another stinker. I picked out a really hard one here deliberately, okay? If we times, we add them, but then we've got to divide. And if we divide, we take away. Now, 9 take away 9 is 0. So that's the answer. Right? A lot of people will put in m, but actually what the rule tells us is anything to the power 0 is 1. Try and remember that. Anything with a 0 is 1. Okay? Here, 2 cubed is 8. So if it's minus 3, it's 1 over 8. Anything to the power 0 is 1. We're on to standard form. Okay. Here, guys, we want the decimal point after the first digit. So this would be 4.2 times 10. And because we're jumping down the number, we jump in 4 places down the number to get it there. 1 jump, 2 jumps, 3 jumps, and then 4 jumps to put it in there between the 4 and the 2. Compared to this, where we're jumping up the number. So it'll be 7.23. But to get there, we put our pen at the end and we jump up 1, 2, 3, 4, 5 places. And remember that it's in standard form, that's times 10 to the power 5. So we can all get that. Then we might be asked to do some calculations. Okay. We don't have a calculator. So best way to do these is to change them into numbers. So this one, 4 times 10, 4.7 times 10 is 47. Times another 10, that's times another 10, that's 3 times the fourth 10, and then times the fifth 10. So you end up with 4 zeros, even though there's a 5 there, because the first times 10 is just jumping it over there. And we're taking away from that 62. I'm going to write it up here for a minute. 62 with 3 zeros. Now, we've got to be careful if we haven't got a calculator doing this, because we should line up from this side. 0, 0, 0, 2, 6. Okay, and we're not, if it's add, we'd add these, but here we're taking away. 0 take away 0, 0 take away 0, 0 take away 0, 0 take away 2, we need to borrow. 10 take away 2 is 8, 6 take away 6 is nothing, and 4 take away, there's nothing in there, is that. And then put your answer back into standard form, so 4.08 times 10 to the power 5 jumps, I believe. 1, 2, 3, 4, 5. Okay, dividing, same thing. 72 with 5 zeros. 1, 2, 3, 4, 5. Divided by 2 with 2 zeros. Okay, cancel your zeros. All right, half of 72 is 36. How many zeros have I got left? 1, 2, 3. Put them on the end. And then write your answer in standard form. Okay. Now, you can do that with all of these, right? The adding one should be okay. Again, like I said, change it to a number. Change it to a number. That one's slightly bigger number. Put that one on top. Put that one underneath. You know, finish that off for me. Add them up this time, okay? The one that's awkward here is this times in one, right? Times in, I don't think I would do in standard form. Times in, I think we're going to times the numbers, right? No calculator, a bit naughty as well. So 2 times 7.8, double it, is 15.6. And basically, we're going to add, because we're times, and basically, because we're doing it effectively, we're doing this. And earlier on, we said if they are the same thing, they're both 10s, then if you're times and you add the little numbers, so minus 4 add 9, minus 4 add 9 is that, and that goes there. So I've literally times those numbers together. This isn't like algebra double brackets. This isn't like FOIL or smiley face. This is literally times the numbers to get 15.6, and then times the 10s together by adding the little numbers, okay? You could have done that up here, look, as well. You could have divided those. Half of 7.2 is 3.6. And because we're dividing, you take away the little numbers and you've got the same answer. So timesing and dividing, you can do like that, or you can change them to numbers and do them like that. But adding and taking away, the most obvious questions, do them like this. Let me just check how long I've got left on my 15-minute video. About 2 minutes left to see if we can get a couple more topics in for tonight. Okay. With a calculator, lovely people, right? That's one way, with a calculator, or divide the number by 100 to find 1% and times by 39. They are doing the same thing, okay? If it's fractions, it's divide by the bottom times by the top. It's with a calculator here, though, okay? Because it actually then wants you to round your answer to the nearest whole number. It's with a calculator, guys, right? So again, like here, you can put that in as 0.550 or 0.5 times, put it in your calculator like that, right? Just like the word of means times, just like you did up here. Change the percent to a decimal and do it like that, okay? A time question. We don't do it in hours. I haven't even read this. We do not work in hours. I want to be changing that. All right, and then 360 plus 15. Also remember to OCW. So what we've done first of all is change that into minutes. I now want to find 2/5 of this. So I'm going to take that 375, divide by the bottom, and times by the top. Okay, work that out, and then take that away from the 375 to work out what's left. You know, how much time you spent on the rest of the task, because the 2/5 was done on planning. And then change your answer back into hours and minutes. Keep going, right? You can do that. Yeah, look, you could call this 0.125, right? Times 1176. Alternatively, 1176 divided by 100 times 12 and a half.